Hello, this is Mrs. Sargent, and this is lesson 7.5% yield. So we've talked about our stoichiometric calculations, and those are going to talk about how much can be produced of one of our products based off of a certain starting amount, and if the reaction goes to completion. But sometimes when we're working in the labs, not everything goes to completion. So that's what we're going to talk today about with percent yield. So our first question says, how many grams of silver can be created with 20.5 grams of copper when it reacts with an excess silver nitrate solution? So we are given 20.5 grams of copper, and we want to determine the grams of silver that can be produced. So these are just like our normal stoichiometry calculations that we have already been working with in this unit. We're going to start with the 20.5 grams of copper. And since we're given a mass, we need the molar mass. And for a single element, the molar mass comes from the periodic table, the average atomic mass. So 1 mole of copper has a molar mass of 63.55 grams. So now we've converted from grams to moles. So then we need to look at our chemical equation, and we have 1 mole of copper. We want to convert from copper, though, to silver, and we have 2 moles of silver. But since we want grams, we have to find out the molar mass of silver. So we're going to again look at the periodic table and find the average atomic mass for silver, which is the molar mass, which is 107.87 grams per mole. So take a look back here. All of our units should cancel except for grams of silver, and they do. So we're going to take 20.5 times 2 times 107.87, then divide that by 63.55, and I got 69.59 grams of silver. Okay, so this calculation is nothing different than what we've already been working with in this unit. Percent yield takes the actual yield, this is going to come from the experiment, divided by the theoretical, what we just calculated from the stoichiometry, and multiply it by 100. So we got a theoretical yield on the last slide of 69.59, but we want to know what the percent yield is if only 40.3 grams of silver were actually made. So percent yield equals the actual, the 40.3 grams of silver, divided by the theoretical, which is 69.59 grams of silver, and then multiply that by 100. And I got 57.91%. So 57.91% of the silver that could be made was actually made in the lab. So just to define theoretical yield, the theoretical yield is the amount of product that can be made if all of the reactants are used up. This is predicted by your stoichiometry calculation. So this is, in a perfect world, this is how much can be produced. Actual yield is the amount of product that is actually made. This is going to be determined by performing the experiment. So our next problem says determine the theoretical yield of water if 10 grams of methane is burned in oxygen. So it's combustion reaction, so we need oxygen in order for it to burn. We want the theoretical yield of water. And most of the time when you're working with percent yield, you're going to be trying to find a gram, mass in grams, because that is what you're going to be able to measure in the lab. And if you take a look down here at the percent yield question, it says grams of water. So the theoretical yield of water is going to be grams of H2O. Go ahead and pause the video and try to set this one up on your own. Welcome back. So we're going to have 10 grams of CH4. And then we need the molar mass of CH4. So carbon is 12.01. And hydrogen is 1.01. We have 1 atom of carbon and 4 atoms of hydrogen. Add these together and we're going to get 16.05 grams per mole for our molar mass. So 16.05 grams of CH4 is what 1 mole of CH4 has a mass of. So then we need to look at our chemical equation for our moldable ratio. We have 1 mole of CH4 and we have 2 moles of water. And then we're also going to have to find the molar mass of water. So hydrogen, its average atomic mass is 1.01. There's 2 atoms there, so that's 2.02. Oxygen is 16. There's 1 atom, so that's 16. Add those together, we get 18.02 grams per mole. So we're going to put 18.02 grams of water over 1 mole of water. So 10 times 2 times 18.02. Then we're going to divide that by 16.05. And I got a mass of 22.445 grams of H2O. So this is our theoretical yield that we just calculated right here. So now we want to do the percent yield. So percent yield equals the actual divided by the theoretical. So our actual is the 19.5 grams that was produced, divided by the theoretical that comes from our stoichiometry, which is the 22.45 grams of water. Multiply that by 100. 19.5 divided by 22.45 times 100 is going to give us 86.86%. Okay. Go ahead and check your answers on those. Hopefully you're on the right track. So we've talked about percent yield. The other thing we're going to talk about is percent error. We talked about percent error at the very beginning of the year in our matter and measurement unit, but percent error is the absolute value of the actual minus the theoretical, so this is going to give us a positive value, that's what the absolute value bars do, divided by the theoretical and then multiplied by 100. But since we've already found the percent yield, we can take 100% minus the percent yield to get the percent error. Both of these are going to give us the same value. So let's try this with one other problem here. So we're asked How many grams of magnesium chloride are produced when 55.6 grams of hydrochloric acid fully reacts with magnesium metal? So we're going to start with that number and unit that we are given in the problem. And we need the molar mass of hydrochloric acid. So hydrogen is 1.01, and we have one atom of that. So that's going to be 1.01. Chlorine's average atomic mass is 35.45. We have one atom there again. So this is going to be 35.45. So add these two together, and we should get 36.46 grams per mole. So we're going to have 36.46 grams of hydrochloric acid on the bottom, 1 mole of hydrochloric acid on the top. Look to the chemical equation. Well, we have 2 moles of hydrochloric acid in the chemical equation. We want to go from hydrochloric acid to magnesium chloride. Well, there's 1 mole of magnesium chloride in our chemical equation. So then we need the molar mass of magnesium chloride. Magnesium's average atomic mass is 24.31. And we have one atom of that. So it's going to equal 24.31. And chlorine is 35.45. We have 2 atoms of chlorine, so that's going to equal 70.90. Add those together, and you should get a molar mass of 95.21 grams per mole. So we're going to have 95.21 grams of magnesium chloride over 1 mole of magnesium chloride. So grams of hydrochloric acid cancel, moles of hydrochloric acid cancel, moles of magnesium chloride cancel. We're going to be left with grams of magnesium chloride. So we're going to take 55.6 times 95.21, divide that by 36.46 times 2. And I got 72. Sorry, my pen's freaking out on me. 72.6. Like I said, pen is freaking out. 0.60 grams of magnesium chloride. Come on. Sorry for the delay here. So that is our theoretical yield. So now for percent yield, we're going to take this actual, which is the 71 grams of magnesium chloride, divided by the theoretical that we calculated to be 72.60 grams of magnesium chloride. Multiply that by 100, and I got a percentage of 97.79%. So percent error, we're going to take, so percent error equals 100% minus 97.79%, and you should get a 2.21% error. So that's it for this lesson. Go ahead and take a look at the practice problems regarding percent error, and if you have any questions, be sure to stop by and ask me questions. Thanks. Have a great day.